Hello, welcome to the video number 7 of the series Exploring ROS with a two-wheeled robot. My name is Marco Arruda, and for this video we are going to have a wall following algorithm using the same robot we have worked in the previous videos. So this video is going to be quite different. We are going to use RDS as usual. If you don't have an account yet, you can create one and use RDS for free, just following the link at the description of this video. After having your account, you can open a project in RDS. If you have the project already created following the previous tutorials, you can just open your project from the last video. And another option is just to clone the repositories, which are also in the description of this video. Okay, so this time I'm gonna have in the right side of my desktop here the simulation running, so you can see the robot performing the task. Let me change the position of the robot because you have been seeing already the robot following this wall here. So let's change to the another one. Let's put the robot more or less right here. Okay, great. And now let's take a look on the algorithm. Okay, so you have created before the go to point algorithm script, obstacle avoidance and reading laser, and this time you have to have the same code as I do here in my workspace, only this file here, follow wall.py script. Okay, so let me put the font a little bigger. Okay, great. So as you can see, we are just importing the ROS.py library, which is the most important, of course, because we are working with Python and ROS. We are also working with a laser, so laser scan, and publish to the top key, which makes the robot move, command velocity, which is twist message. Okay, so let's take a look here what we have. So I'm declaring a global variable here called pub underscore, which is our publisher in our main function. Let's minimize the functions here just to not make confusion. We don't have to see all of them yet. I have also defined the regions of the laser. We have seen already this variable here, region, the right region of the robot, front right, front left, and left side of the robot. Here is the same thing. Okay, I am defining here a state variable for the robot and also a state dictionary, because we are going to have 3 states basically here. Okay, so if the robot cannot see any wall, we have the first state, which is find a wall. If the robot has seen a wall, its default behavior is to turn to the left side, so we are going to keep the wall in our right side. And finally, after having the wall in our right side, in the right side of the robot, we are going to follow the wall, okay, which is the main task here. So let's take a look in our main function. We are using the publisher here, defined at the beginning of the script, initializing our node. The name, it doesn't matter, so you can change it and put the name you prefer. I am defining the publisher to the command velocity and reading the laser of the same topic we have been reading in the previous videos. I'm defining a rate here of 20 Hz. For me, it's enough to make the robot work like this, as you can see. And inside our loop, we are defining a message, and depending on the state, we are getting the message values from a function. So for the state number 0, we have find wall. For the state number 1, we have turn left. And the last state, number 2, we have the main task, which is follow the wall. Okay. Finally, we are publishing the message to the command velocity and put the node to sleep to the next time we have to perform the same tasks. So let's take a look here in the callback laser. So we are just feeding the regions variable. So we are using the global variable here, regions on this underscore, and we are calling this function take action, which is a function. This function is just reading the values from the laser, and we are changing the state of the algorithm. Okay, so we have this function here, change state, which is basically just working with the global variables, state and state dictionary. And if the state is different than the previous one, we change the name of the variable and also print the name of the state we are gonna be. Okay, so wall follower, the number of the state, and the description of the state of the robot. Okay, so after taking an action based on the reading of the laser, we are using the front region, front left and front right, and I have changed here from the obstacle avoidance algorithm the distance, so I put in a variable here because I don't want to change it in a lot of places every time. I put here 1.5 meters, and I have used the variable here. Okay, so I am working with all the possibilities, H possibilities of 3 variables combination. Okay, and finally, after changing the state, we have here our loop, which is taking the number of the state we have and assigning to a function the task to give the robot's velocity. Okay, so in the case of the robot don't see any obstacle in front of it, we have to find a wall. So basically, to find a wall, we are just going forward and also turning to the right side. Okay, so let's take a look here. I'm gonna have the terminal so you can see the state is changing all the time. Let's put the robot in a position which we cannot see any obstacle. Actually, the laser can't detect the obstacle, but we are not using it because the distance of the robot to the obstacle is less than 1.5 meters. Okay, so let's see in this case here. The robot cannot see the obstacle, so it's trying to find a wall, and it's going forward and turning to the right side, and it has just found the wall. And then, okay, we are going around the obstacle, so we cannot see just one state working. So let's try to put the robot more or less right here. Okay, so the robot now is trying to find the wall. It has just found the wall, and now it's following the wall. Okay, and also we have to consider the another state, which is turn left. So which is gonna happen when the robot finds an obstacle and it's right in front of the robot. So the robot's trying to find a wall. Okay, and it has just found the wall here, the obstacle, and it's turning to the left side because you want to keep the wall in the right side of the robot. Okay, this is just a standard that I have adopted for my algorithm. If you want, if you prefer, you can define that your robot will follow a wall and keep it in its left side. Okay, it doesn't matter. So finally, to the turn left algorithm, I am just defining and putting an angular velocity here around the z-axis. Okay, so here it's positive, which is the opposite of the find wall algorithm, which is where the robot's turning to the right side. Okay, and finally the follow wall algorithm, which is basically go straight ahead. Okay, so there is no mystery here. If the robot has the wall in its right side, just go straight ahead. And we know that there is something in the right side because we're using the laser and its data. Okay, so basically that's it. I hope you enjoy it. It's also important to pay attention to these values here because if you are working with a different robot, okay, I have to tell you that I have done these values for my robot and my application, so I may have some problems if I try to use the same algorithm, but not just the same algorithm, but the same values here that have worked for my robot if I try to use in a different robot. Of course, if I try to use in a bigger robot, I have to change also the distance that I am detecting the wall, because otherwise we're gonna just go with the robot and crash the robot against the wall. Okay, so you have to pay attention to these variables here. Okay, they were tuned for this robot and this scenario. Okay, it's very important to have it in mind. So basically that's it. I hope you enjoy. Don't forget, if you like this kind of video and if you want to keep following this video series, we are publishing a new video every week, and for our channel we publish a new video every day, so don't forget to subscribe and press the bell to be notified every time we publish something new. See you!